So, yes, the recording. Yes, recording is started. So, basically, what we are going to discuss today in this topic, that is transfer of thermal energy. There are several modes of transfer of thermal energy, and they are actually the conduction, convection, radiation, and then total transfer. So, all these are equally applied. Somehow, they are applied in different formats, but they are actually the transfers of. They are the main modes of heat transfer. So here we go. My voice clear now?
Yes, sir.
Okay. So basically, when we talk about this this thermal energy is the total kinetic energy of the molecules of the atom of any body, or in other words, that is the potential energy. But in the gases, we call it the kinetic energy. But kinetic energy means something that the total energy in solid, liquid, and gases, that is a little bit different. For example, in solids, liquids, and gases, as I told you, that the internal energy is sum of molecular's kinetic energy and molecular's potential energy. So what happens in solids? The kinetic energy is very small, that is approximately zero, but maximum is the kinetic energy, and you can say total energy is in the form of total internal energy is in the form of potential. In liquids, the kinetic energy is partially they have kinetic energy, and partially they have potential energy, right? So they are 50-50. But in gases, kinetic energy is maximum, right? And internal energy is mainly in the form of kinetic energy, but potential energy is almost zero, because the molecules are not having intermolecular forces, because that energy is due to intermolecular forces. That is why this happens. Now, due to this all discussion, what did we or what do we say here? That these all energies which are basically here, the energy transferred from the high temperature to the low temperature in the object, right? This is another important thing, that how do we transfer the energy? The energy is transferred from higher temperature to the lower temperature. Is it clear to you? And then the amount of thermal energy that is transferred in the amount of heat that flows. Yani the heat energy is basically the rate of flow of heat. Then the thermal energy is transferred in three different ways: conduction, convection, and radiation. So these three are basically the modes of heat transfer. So from this slide, what did you learn? That all the bodies, they have the temperature, definitely they have kinetic energy, and due to difference of temperature, the energy is being transferred, or thermal energy is transferred. And if those bodies which have higher temperature, the energy thermal energy is transferred from those body to the lower temperature energy bodies. So three modes of heat transfer I told you about: conduction, convection, and radiation. So what is conduction? Basically, conduction is that process of thermal energy by which the energy is transferred through the medium from one particle to another due to vibration of particles. This is very simple to understand, that conduction is due to conduction is due to vibration of particles. So vibration takes place only in solids. That is why the kinetic energy, this mode of heat transfer, is applicable only in solids. It is very important that the solids are good conductors as compared to that of the liquids and gases, right? So here is the main mechanism of heat transfer, the energy transfer. Do you know? This is the high temperature zone. This is the low temperature. The other one is the low temperature zone. For example, here, yeah, here it is high temperature zone. This is low temperature zone. So what did you notice? That the molecules have more vibration here. Did you notice this one? The molecules have higher vibration at these points. As we are moving to the lower ends, the vibration of the molecules is decreased, and here the vibration is very little. That is why, due to this vibration, they interact with each other. These molecules will interact, the left ones, they will interact with the left ones, and so on. So in this way, the energy is transferred from one point to another point. So remember this thing: when one end of the rod is heated, the molecules gain the energy and they vibrate faster. And these molecules collide with the other less energetic molecules, neighbors, and this energy transfer takes place to the neighboring atoms. And due to that, the energy is transferred from one point to another point. That is basically called the conduction method. in the solids. But there is one main problem. You know, there are some electrons as well. So when you are going to heat the substances, the atoms vibrate and interact with each other, whereas the electrons move physically from one point to another point, from the hotter end to the colder end. That is why that those substances in which the free electrons are available, yani you know that these substances are the metals. So in the metals, the conduction is very high. That is why I believe that you are known with that mechanism, that metals are the good conductors as compared to that of the non-metals. That is the only reason that when they are heated, they have vibration of atoms, as well as the electrons are transferred from one point to another point. So please be aware of this method, that why the metals are good conductors. So this is the detail, that this process is much faster than that of the conduction of the vibration of the molecules in the body. So hence the metals. Yeah, this is that point what I have mentioned for you. That this is the reason right here. Due to this, the metals are good conductors than that of the non-metals. Okay, so remember this point. And one more thing, that conduction cannot take place in the vacuum. Conduction is very poor in the liquids and the gases. That is why the best conductors are the metals, right? Conductors. I'm just dividing the material into categories. So metals are the best conductors, not anything else. Conductors, right? And then amongst all substances, and then solids are fair fairly good conductors, right? Overall solids, but in the solids, metals are the best ones. So you have to keep these points with you. Okay. Now here is an example, a demonstration, rather you can say an illustration, or what, that we have different type of materials. One of them is the metal. Sorry. The one of them is the copper rod. The second one is aluminium rod. Third one is iron rod. Fourth one is steel rod. So that rod, they all were having the same amount of specs from this point to this point. That was completely, they were completely wrapped with the with the solid wax. And now the hot water is placed, boiling water is placed in the container. This conductor, this is a metal box. So what will happen, that metal box will transfer the energy, and that material is the best conductor, which has melted the most wax. So that is why copper is the best conductor in this example. If you see that, is it, do you agree? The same type of questions are asked to you with the beads. So here, the conduction, good conductors and poor conductors, is a list. So in gold, silver, copper, iron, brass. This is the ease of the conduction. And then you have glass, stone, water, plastic, wood. This is not mandatory to remember that, memorize that. But these are some past paper questions from your conduction. The iron bar steel with one end of the fire. One end is in the fire, and the other end, because it is too hot. Because it transfers the heat by conduction. Okay, so these type of questions will be asked to you. Yes, the same question again. This is the diagram A before heating, and this is the diagram B after heating. Every rod was having one, two, three, four beads connected with the wax, right? Attached with the wax. So when you have heated these rods, it has all four. It has two, it has three, and it has one left. Yani, this is the most it is conducting the lot of heat. That is why it is the best conductor, right? You got my point. So it is the best conductor. So these type of questions are asked to you from this. There are a lot of questions in this on these slides. I will just go ahead because there are 78 slides I have to discuss. So the rod is made up of copper and the wood joined together, right? Rod and copper are wood joined together. And here on the junction, what do? You just heat it up. A paper is wrapped around the around this yani on the rod, in on that rod, some of the part is copper, some of the part is wood. So when you are going to heat that up, a paper is wrapped around it, and when you are going to heat this up, what will happen? The paper would get brown from one side and not from the other side. Then this is the question, right? uh, After the rod is heated, join the center about a minute. Where would where would the lowest temperature be? So the lowest temperature will be at point A, because that will not transfer the energy a lot. The same question is asked to you from same diagram of the paper, that a paper is wrapped around it and it is heated. So the side from where the paper is getting brown, that is the best conductor, right? So there are so many questions which are asked from this. So now I'm going to discuss about convection. Beta, convection is that mode of heat transfer which takes place in fluids. Where? In fluids. Fluids mean gases and liquids. So this is typically very easy thing, that convection takes place in gases and liquids. So whenever you are talking about the conduct convection, you have to prefer that, okay, the convection will take place only in solids and liquids. So why do the convection, or what is the mechanism of convection, right? The mechanism of convection is that we have the liquids or gases, they are the poor thermal conductor, right? But the particles move all the time. What happens? Their particles move all the time. And when the liquid or the gas is heated, the energy is transferred to the particles, right? And that causes them to move more faster or further away. Yani, there are several steps in convection. I will explain on the next slide. The convection is the process by which the thermal energy is transferred from one place to another place by the movement of the particles. The most important definition you can say of the convection, this is that the convection is that process of thermal energy transfer in which the molecules move from one point to another point. Yani a bulk movement of the particle is taking place in convection, where in conduction, the vibration of the particle was taking place. Now this is a demonstration for convection. Convection in the liquid mean you have placed a liquid, and inside that there is a purple streak, I mean a sort of indicator, you can say, that is placed in the liquid flask, and that is heated from one side. When it is heated, did you notice that as you are heating it up, it is moving upward? What is happening to that? It is moving upward, and it is moving upward. It means this is actually the bulk movement of the molecules. So this the when the liquid molecules are heated up, what happened? They move apart. What happens to them? When the liquid molecules are heated, they expand, and then they become less denser. This all is very important to know. And they float upwards. All these points, right? Cold and dense liquid moves downward to replace it, and this returns to get heated up. Yani, in turns, the cold molecules will come down and the hot molecules will go up. And due to that, what happens? This is the hot molecules, they are going up, and the cold molecules, they will move down. And in this way, they will be heated up and so on. They will move away. So, this is basically a sort of method of the conduction, sorry, convection. In convection in gases can be demonstrated by this example. There is a box, and in that box, there is a lighted candle just to heat up that smoke what we are going to provide it. And there is a smoldering paper, yani that is a smoke paper, right? And that is placed inside. Due to that, this is actually the glass window through which you can see that all. So, did you notice that cold molecules are the molecules which are cold? They come down, they sink down, then they move towards. Why do they move? Because the hot molecules move upward. What happens to the hot molecules? Here the gas is heated up. These molecules are moving upward, and due to that, there is a space created. And to fill that space, actually your these molecules are moving from here to here. So this is actually a bulk movement of the molecules. So convection occurs when more readily in the gases than that of the liquid, because they expand much than more than that of the liquids when their temperature rises. Is this clear to everyone? So here, this is a past paper question, and an experiment is carried out as shown in the diagram. Right, in this experiment, there's a Bunsen burner. You have a tube. You have a steam is there. Boiling water is there. Glass tube, and then metal gauze to keep the ice down, and ice. So, beta, why? First of all, why do we keep this wire gauze? To keep this ice on the bottom, because it floats. Secondly, why it is very why the ice takes a long time to melt? Because when the water is heated from here, this is the water heated. When the water is heated, all the hot water moves up. It is a very poor conductor, so heat transfer to the ice is at very low rate. That is why it takes a long time, right? So why does the ice takes a long time to melt, even though the water is at the top of the tube and is boiling? The convection never occurs in water. No, convection occurs. Ice is a poor conductor of heat. No, the gauze prevents the energy to reach to the ice. No, the water is a poor conductor of the heat. That is actually the reason. Are you getting my point? Is this clear to everyone? In which line in the table is the correct about the conduction and the convection? So, conduction that can happen in the solids, yeah, option A, and convection that can happen in the solid, no, that is incorrect. That is why this option is discarded. Conduction can take place in solid, and convection takes place only in fluids. Yes, this is the right option. Conduction only happens in the fluids. No, totally incorrect. So that is why this option is discarded. Only happens in the fluid. No, this option is incorrect again. So option B is correct. So these type of questions are asked for you. The density changes are responsible for which method of the thermal energy transfer? So in which method of the thermal energy transfer, I told you that uh, yani, density was changing. Yes, density was changing in the process of thermal energy transfer, that was convection. You got the point? Is it clear to everyone?
Yes, sir.
Okay, so that is basically convection only. Okay, now here this is one of the tricky questions in your past paper. A heating element is positioned in a narrow sealed tube of the liquid. What would be the best place to position the heating uh, element in order to obtain the best circulation of the liquid through the tube? Yes, there are several positions. So, okay, in option it is mentioned that it is C, but when you will place that heating element in the C, what will happen? The uh, hot air will move up, okay, and the space will be created. Due to that, the cold air will sink down from here, and it will move through this. You got it? And due to that, there will be a complete circle that will be running throughout. So the hot and cold air that will flow. You got my point? So basically, hot air moves up and cold air moves down. So in this way, this is the best position to place the filament. You got the point? Okay. The diagram shows a block of the ice placed in the warm room. Okay. In at which point is the temperature be the lowest? Most of the students get trapped in this. That's sir B. Why? Which is incorrect. The students think that when the air on the ice will get cold and the cold air will move up. No. The air which is basically uh, in touch with the ice, that will cool down, and the cold air sinks down. So that is why this is incorrect. This is correct, that the temperature will be lowest over here, not the here. The same question is again once again asked in one of the past papers, instead of ice, it was a hot piece of metal. Hot piece of metal. Okay, hot block of metal, you can say. So there were two thermometers, thermometer A and thermometer B. So which thermometer will give a greater change in temperature? So you know that in that case thermometer B, because hot air will move up. So this is how you have to maintain all these concepts of, yeah, oh yeah, this is that question again, thermometer wala question. Okay, so the thermometer X is held above an ice cube and the thermometer Y is held below the ice cube, right at the same distance. After several minutes, the reading on one of the thermometer changes. The ice cube does not melt. Did you see the question? Which thermometer reading changes and why? So, as I told you, that the air is getting colder, so that is why cold air will sink down and that will reach to the thermometer Y, and thermometer Y reading will decrease. What will happen? The reading of the thermometer Y will decrease. So here you can answer that, C, Y option correct, because cold air falls from the ice cube. You got it? Is this clear to everyone? So this is how you have several questions for the past paper practice on this slide. Now describe the process of heat transfer by radiation. This is the next third method of transfer of thermal energy, and I told you that third method is basically radiation. So radiation is basically that mode of heat transfer in which the heat is transferred in the form of radiation, yani waves, electromagnetic waves. Remember this thing, electromagnetic waves. So when they transfer in the form of electromagnetic waves, we can consider that yes, these are basically the waves, or these are the radiation. So here there's a firework, and there are three places where the transfer of energy is being taking place. The Here it is by convection and radiation plus radiations, because the radiations are also moving up. Here only radiation, because convection does not take place horizontally, and here only conduction. You got this point? Okay. The source of energy in the radiation transmits energy in the form of waves. They are known as infrared radiation. So this is another question of your past papers, that what is the name of these what is the name of these thermal radiations? They are also named as infrared radiations, right? And when they are absorbed, when the energy of the waves are transferred into the thermal energy and received by the body. So basically, this is the time when the radiations are absorbed. So radiation is the mean of, this is again a past paper question. The radiation is the mean of energy transfer from sun, and sun's energy travel to the earth as an electromagnetic wave with the speed of light. So this is very important slide, that there are so many informations in that, and these all are asked to you. So radiation is the only mode of heat transfer which takes place in vacuum. Okay, radiation is only mode of heat transfer, mode of heat transfer takes place in vacuum. Okay, so remember these all points for the for these, and for the radiations. Here we'll have some sort of comparison of the good radiators and poor radiators of energy, thermal radiations. So this topic deals with emission and absorption of radiation. So if you have two blocks, one is dull black surface and the second one is shiny surface, and both have hot water inside, right? The object which is dull black, its temperature will rise quickly. It will provide good cooling rate. That is why the we can conclude that the dark colors are basically the best emitters of radiations, right? Are black colors, you can say. Black or dark colors are best emitters. This is very important topic. right? Emitters as well as I can say absorbers, right? Now, that is why what do we have? We have different type of application areas in our daily life in which we paint these capillaries as black, right? The cooling fins are painted black of the refrigerator, dull black, because they let the energy to go out more quickly, right? And here the poor example of poor radiators. So these silvery polished are aluminum foils. They are the poor radiators. So that is why the marathon players, they are advised to use these just to keep their energy contained, right? Because the silver is a silver color. Silver color is best emitter. Sorry, best reflector, not emitter. Best reflector. Okay, best reflector of radiations. So that is why we have several application areas. Here there are two metal discs. They are equidistant from a candle, and they have been heated up. And when they are heated up, that disc which has wax closer to it, wax is attached, so that cork is falling because it's heated up quickly, so they are the best absorber as well. So I simplified this all discussion that the black or dark colors are best emitters and best radiators. You got the point? Is this clear to everyone? Yep. Is it clear to all? Okay, examples of good absorbers. This is basically the naphtha, or you can say the asbestos, which bitumen that which we place on the roads. That is the best absorber. Then examples of the poor reflectors. You can say the poor reflectors are sorry, poor absorbers are silvery polished are white colors. Where the sun radiation rate is higher, where we use the fuel storage tanks are sprayed with shiny silver and paint to reflect the radiations from the sun, so that the heat or temperature should not rise and they should not be harmful. The rate of the energy transfer by the radiation is affected by these three factors: the surface temperature, right? Color and texture and surface area. Yani these are actually those points which are important to now note that the this deals with the surface temperature, surface area, and texture of the surface. So these are three factors which affect your radiations, right? So this is the comparison chart that silvery polished surfaces, they have they are they are basically the good reflectors, right? These are good reflectors but poor absorbers, right? They are good reflectors but poor absorbers. Okay, remember this thing. How does this is again a past paper question, how does the thermal energy is heated traveled through the vacuum? So as I answered this question in my topic between the earth and the sun, so that is the only way, that is by convection, right? So be aware of these type of questions. And yes, here this is a question: the bread can be cooked by placing it below but not touching the heating element. Heating element is above, bread is cooked, placing it below. Now, the question is how the energy is reaching to the bread from the filament, sorry, from the element of the bread, element to the bread. So that is only, yes, that is only radiation. Okay. So you have to keep all these points in your mind. For example, there are two uh, blocks or cylinders. One is white, one is black. The white is actually placed. They are placed in the infrared heater, in front of infrared heater. So which they have hot water inside. Sorry. sorry, they have hot water inside, and once they have cold water inside. Yeah, that is the question. Now the cold water in the black can heat it up more quickly than the cold water in the white can. Right? What is the reason? The reason is that the black bodies are the best absorbers of the radiation. Right? The black colors are best absorbers of radiations. So you get this point? Is this clear to everyone? Right. So basically, there are some application areas. The total transfer of energy. This is the last, hopefully, the discussion of this topic. Total energy transfer. Beta, the total energy transfer takes place in different, yani, in different application areas through all these type of mechanisms. Here, there is a thermal image of a house which is radiating the heat through doors and the windows in the form of radiations, then conduction and convection all together. So here is basically this segmented diagram that heat transfer in the home. So in the home, the conduction takes place between the person and the floor. Radiation takes place from person to the walls. Convection takes place within the room. Then convection takes place around the walls. Then conduction takes place from walls through the surrounding, and then radiation takes place in the roof. So these all are actually some modes by which the heat is transferred. Now here is a sort of application area that what happens in the geysers, water geysers, and this is actually a diagram of your water geyser. You can say the hot. There is one tank of water, only one tank. Here the water is heated, right, and the hot water moves up through this tunnel, and it is stored here. Right, when it is stored here, you can simply say that okay, yes, the water is now stored here, and the top layer will have the hot water and the bottom layer will have cold water. And due to that, what will happen, you will have uh, yes, you will have a wall through which you will get this cold water, sorry, hot water in, right, and cold water here. So from one tank or one tap, you are getting both the water. So it's an interesting application of the water. So I believe that it will be clear to you. Then one of the best example is the thermos flask. So in thermos flask, did you notice there is a vacuum placed between this, and then there are some rubber seals, right? Silvery polished surface, gas, glass or steel walls, and then caps with the removed air and the stoppers. So all these enhance the containing of the heat properly. So when you have uh, when you have a thermos flask, uh, the caps are used to prevent the convection. Okay, and these insulations are used. Insulations are used to decrease the conduction. This stopper is also to prevent the convection or evaporation, right? And the silvery polished surface, internal and external, to prevent the radiations. So these all are the discussion about your um, thermal energy transfer. Hopefully, that topic would be clear to you. I have a lot of slides in this to discuss with you. These all are your past paper questions, and hopefully, I'm just sending this file to you. If you have any question, any problem, you people can ask me. Okay, just go through all these questions, although they are basically the MCQs type. For example, for this is the one of the best examples of the time, the best question of the time. A double glazed windows has two sheets of the glass separated by the air layer of air. The thermal energy is conducted and convected through the layer of air. The amount of conduction and convection varies with the thickness of the layer of the air, also shown in the graph, right? So if you are using more air, so check this one out. This is the total energy transfer. This is the thickness of the layer of the air in there, and this is the thermal energy transfer. So if you are using no air, right, lot of energy is being transferred. But there is a several layer of air at which the energy by convection is increased and energy by conduction is decreased, because air is a poor conductor. So that is why there is a sort of balance required. Okay, so what is the best level, or what is the best thickness? That is 1 centimeter thickness, at which the air, the total energy transfer will be very less, right? So remember this thing, that which thickness of the air product produces the smallest energy transfer, and why. So this is the 1 centimeter, because the total thermal energy transfer is least. You got this point? So please remember these questions. These are very important questions, and hopefully they will help you out. See you tomorrow, inshallah, at the same time. Any question, anything you want to ask me?